Hello everyone and welcome to another episode of Power Logic. So today we're going to be starting the 2022 AMC 12B solutions. Let's go to problem 1. Define x times y to be the absolute value of x minus y for all real numbers x and y. What is the value of this expression? So we just start with calculating each separate values. The first one is the absolute value of 1 minus the absolute value of 2 minus 3. That's equal to 0. And the second one is just 1 minus the absolute value of 1 minus 2 minus 3, that's equal to 2. So 0 minus 2 is equal to negative 2, which gives us an answer choice A. Let's go to number 2. In rhombus ABCD, point P lies on segment AD such that BP is perpendicular to AD, and AP is equal to 3, PD is equal to 2. What is the area of ABCD? So, from here, because it's rhombus, then we know that all four lengths are actually equal. So now AB is just equal to 3 plus 2, which is equal to 5, because this part is 3 and this part is 2. Now we can just look at this right triangle. Now, anything special with this right triangle? Well, because we know that hypotenuse is equal to 5 and the leg is equal to 3, then we know that our leg must be equal to 4. Well, if you do not believe it, just try and you will see that by doing the Pythagorean theorem, you can see that actually this length is just equal to 4. But it's actually better to just memorize the 3, 4, 5 right triangle triples, since that can actually save some time. Now we know that the leg is equal to 5, or the base is equal to 5, and the height is equal to 4. So this basically means that area is just equal to 5 times 4, which is equal to 20. So giving us an answer of D. Let's go to number 3. Problem 3 says that how many of the first 10 numbers of the sequence are prime numbers? Now let's look at all of these numbers. They seem to be pretty symmetrical, right? Like a number of 1 and followed by a middle of 2 and then the same number of strings of 1. So 121 can actually be written as 110 plus 11. Same idea. 11211, well 11,211. That can be written as this. And so does now, can we factor these? Well, this one's essentially just 11 times 10 plus 1. And this one's 111 times 100 plus 1. And this one's actually 1,111 times 1,000 plus 1. Okay. So these seems to be all factorable. Well, if you do not believe the pattern, then just try some more value and you actually get that none of these are prime. So this basically just gives us easily an answer choice of A, 0. Now let's go to next one. For how many values of constant k will the polynomial x squared plus kx plus 36 have two distinct integer solutions? So basically, if we can actually express it as x minus a times x minus b, such that both a and b are positive integers, or actually not positive integers, just any integers, but a is not equal to b. So if we expand this out, then this one is essentially just the same as x squared minus a plus b, x plus ab. Or you can just verify by Vieta theorem. And if we compare this with the equation that we have, the expression we have, then we can see that AB is equal to 36. And we're going to find, so basically we just want to find the number of possible values of A plus B such that AB is equal to 36. And because this problem didn't specify that we can only allow positive integers, then A and B can also be negative. So now we'll just list all possible cases of AB is equal to 36 and A and B are different positive or negative integers. So AB, we can actually have 1 and 36, 2 and 18, 3 and 12, 4 and 9. And we can also make both of these to be negative. So we can also have negative 1, negative 36, negative 2, negative 18, negative 3, negative 12, and negative 4, negative 9. And we can see that because of the commutative property of addition, then we know that if we swap these orders, then the value of a plus b, which is k, does not even change. So therefore, there are actually just only a total of 8 possible values. Well, you might ask that why doesn't 6 and 6 work? Remember the problem statement that we have, that we need 2 distinct integers, so therefore we're going to exclude the case when a is equal to b is equal to 6. So this just simply gives us an answer choice of b. Okay, so now let's go to number 5. So number 5, well, I don't know what's happening with the top one. Why is it circle out? Well, by the way, I'm just going to leave the PDF after the video under the comment section so that you guys can probably just reference the solutions. Oopsies. Okay, now things start to mess up really badly. Okay. Yeah, okay. Okay, now let's go on to number 5. So number 5 says that the point -1, -2 is rotated 270 clockwise about the point 3, 1. What are the coordinates of this new position? Okay, let's first start by just drawing out a coordinate plane. And we just finished drawing it out. So let's first plot, -1, -2. So -1, -2 should just land somewhere right here. Let's just call this P. And we also have that it's rotated 270 clockwise about the point 3, 1. So basically 3, 1 lies somewhere right here. So, okay. Rotating 270 clockwise is actually the same as rotating 90 degrees clockwise. So basically, this tells us that actually our new coordinate would land in the second quadrant. Okay. Now I want to rotate 270 clockwise, no, 90 degrees clockwise about the position, then we can actually shift the coordinates up. So that actually the new origin is at 3, 1. Okay. So how does that even help? Now we can just draw a line, draw the direct distance from P to the new origin. And basically the fundamental way that rotation works is that we're just going to draw the same line of same distance, and the theta is actually just going to be the angle of rotation, in which case this case would just be 90 degrees. So it's just a right angle. Now let's see that what is the x component and y component of this distance vector. Well, this part, you can just do a subtraction of the x coordinates, which gives us 4, and this one similarly just gives us 3. Now because these two are perpendicular, then this actually just tells us that this part is actually 4 and this part is actually 3. So basically, this entire thing just tells us that the new coordinate will be 3 to the left, 3 units to the left of 3, 1, and 4 units above 3, 1. So basically, the new coordinate is what? So it's just 3 minus 3, 1 plus 4, which is 0, 5. And this essentially just gives us answer choice B. Okay, now proceeding to the next one. Number 6. Consider the following 100 sets of... I don't know what is happening right here, but... Consider the following 100 sets of 10 elements each. 1, 2, 3, 10, 1, 11, 12, 13, and you see the pattern. There's a total of 100 sets. Well, this problem, I would say, is that it's actually really simplified if you actually know or figure out the trick in the contest. But it will actually be a bit tedious if you did not figure out the trick. So basically, first let's start by considering how many multiples are there. How many positive multiples of 7 are there that are below 1000? So to calculate that, we're just going to do the floor value of 1000 divided by 7. And this value just gives us 142. So this tells us that there's actually 142 multiples of 7 that are below 1000. Now, there are actually 100 sets. And all of these sets combined together would actually include all of the numbers from 1 to 1000. So basically, this tells us that there are actually 142 multiples of 7 inside these 100 sets. And what does this tell us? So another thing is that there's going to be either 1 multiples of 7 or 2 multiples of 7. And there's only going to be 1 or 2 multiples of 7 inside each set. Because 7 is actually less than 10 and it's actually less than 14. Now, if you do not believe this pattern, just try some of the new sets and you're going to realize that you can either get 1 multiple of 7 or 2 multiple of 7. Now, how does this even help us? So because this holds true, then therefore there's going to be 100 sets that contains exactly 1 element, and there's going to be 142 minus 100 is equal to 42 sets that will include an additional multiple of 7 from the 1 multiple of 7 that they must contain. So therefore, 42 is just simply our answer. So by the way, I forgot to attach the answer choices to this problem, but the original answer choice are 40, 42, 43, 49, and 50. So therefore, 42 will just be our answer choice simply. Now let's go down to number 7. So Camilla writes down 5 positive integers. The unique mode of these integers is 2 greater than their median, and the median is 2 greater than their arithmetic mean. A lot of information. And what is the least positive value for the mode? Now let's just draw 5 number lines. So okay, let's say that the median is m. Now what does it tell us? Now because the unique mode is 2 greater than the median, and there's only 5 positive occupations, so therefore we know that there will actually be the maximum value, which is this, is actually just the unique mode. It's actually going to be occurring twice, and we know that any numbers that comes before m, which is less than m, must be distinct because this is the unique mode, and recall that mode is actually the number that occurs the most inside this, inside that list. Now let's read the problem again. The problem also tells us that the median is 2 greater than their arithmetic mean, so we know that the median, well actually the mean, is equal to m minus 2. And because it's the mean, then the sum is equal to 5 times m minus 2, which is equal to 5m minus 10. So, okay, now we sum up these numbers. Sum is just equal to 3m plus 4. So basically, let's say that this number is a, this number is b. Then we know that a plus b is actually equal to what? 5 5m minus 10 minus 3m plus 4, which just gives us 2m minus 14. Okay. So basically we want to find the least positive value of m, or the mode. Well, now let's actually look at this value. So because all of these are positive integers, then this basically means that actually the least positive value of m is going to be 9. Well, why is that? Well, the least positive value is 9 because, well, in order for this to be greater than or equal to 0, we must have m is equal to 7. However, we know that a and b are actually less than m, and all of them are positive integers, so there's no way for a and b to be positive and also be greater than 0. So we have a contradiction. Now, what if m is equal to 8? Well, if m is going to be 8, then the sum of a plus b is going to be equal to 2 times 8 minus 14, which is equal to 2. However, we know that a and b must be distinct and they must be positive. But the only way for a plus b to be equal to 2 and a and b are positive are just 1 plus 1. But they're not distinct. So, therefore, the least positive value is 9. However, keep in mind that m is what? M is actually the median. However, we actually want the arithmetic mean. So this basically, no, we actually want the least positive value of the mode. So therefore, it's just equal to m plus 2, which is equal to 11. And that is essentially our answer to this problem, the 11. Now let's go on to problem 8. What is the graph of y to the 4th plus 1 is equal to x to the 4th plus 2y squared? Okay. This seems to be pretty hard to factor. Well, but something intuitive to do in this case would just be try to separate these into x and y. So if we separate this equation, we're going to just get that y to the 4th plus 1 minus 2y squared is equal to x to the 4th. So now we know that this is actually the characteristic equation of a's perfect square. So this one is just y squared plus 1 squared is equal to x squared squared. Now this one actually produces two cases. Well, the first case would just be y squared minus 1 is equal to x squared. So this one just gives us y squared minus x squared is equal to 1. The second case is what? The second case is basically y squared minus 1 is equal to negative x squared. So this one gives us x squared plus y squared is equal to 1. Now, notice that this is actually the equation of an ellipse. No, of a hyperbola. And this one is actually an equation of a circle. So basically this means that this equation right over here actually creates a circle and a hyperbola, which give us the answer D. Now let's go to the next question. The sequence a sub 0, a sub 1, a sub 2 is a strictly increasing sequence of positive integers such that 2 to the a7th power is equal to 2 to the 27th power times a sub 7. What is the minimum value, positive value of a sub 2? Okay. So now we know that, like, let's say if we have that 2 to the a is equal to 2 to the b times c, then we know that c must be written as 2 to the a minus b power, right? So basically, we can just let a sub 7 to be m, or to be 2 to the m. Then how does this even help us? Well, 2 to the a7 can just be written as 2 to the 2 to the m is equal to 2 to the 27 times 2 to the m. Well, because remember that a sub b times a sub c is equal to a sub a to the b plus c's power. From the exponent property, then this just produces an equation of 2 to the m is equal to 27 plus m. Now, just by inspection, we can see that 5 is actually a solution. And the other solution will actually be really hard to find and would actually not be a positive integer. So, well, also you can just see that this one increases faster than this one, and there's actually no positive integers between 0 and 4 that works. So therefore, we know that this one's just going to be 5. So m is equal to 5, which basically means that a sub 7 is equal to 32. Okay. Now, since, well, this one is a strictly increasing arithmetic sequence and a sub 7 is equal to 32, well, let's just say that the sequence is going to be a, comma, a plus d, comma, a plus 2d, comma, dot, dot, dot. Now this one actually corresponds to a sub 0, this one corresponds to a sub 1, this one corresponds to a sub 2. So basically, from here we can see that a sub 7 is actually equal to a sub 0 plus 2d. No, a sub 0 plus 7d. But we actually want to find the minimum value of a sub 2, which is a sub 0 plus 2d. Now we can actually just subtract these two equations, which gives us 5d is equal to 32 minus a sub 2. Well, okay. We want to find the minimum value of a sub 2 such that this equation right over here still holds. Well, however, because it's positive integers, so therefore we know that 2 would actually simply just not work. Well, and simply, we'll just subtract these two equations. 5d is equal to 32 minus a sub 2. So now we just simply try some values. So if a sub 2 is equal to 2, well, this one obviously does not work because 32 is a sub 0 plus 7d, and 5d is 32 minus a sub 2, so d is equal to 6. However, 2 minus 6 is already less than 0, so it's not working. Now what about a sub 2 is equal to 7? Then we know that d is actually equal to 5, but 7 minus 2 times 5 is still less than 0, so it's not working. Now what about a sub 2 is actually equal to 12? Then d is equal to 4, and 12 minus 2 times 4 is actually greater than 0, so this works. So therefore, this tells us that the minimum value of a sub 2 is just b, 12. Now let's go on to number 10. Regular hexagon ABCDEF has silence 2, excuse me. Let G be the midpoint of AB, and let H be the midpoint of DE. What is the perimeter of GCHF? The quadrilateral. Okay, now let's just start by drawing out a regular hexagon. And let G be the midpoint of AB and H be the midpoint of DE. So let's first just mark up all the vertices. So, okay, now let G be the midpoint of AB, and let H be the midpoint of DE. What is the perimeter of GCHF? So we draw a connection. Sorry for this terrible drawing, but we can actually see that because this is actually symmetrical, so therefore all these lengths are essentially just the same. So it's a rhombus. So now from here, well, because we know that the silence is 2, so therefore the silence of AG is actually equal to 2 over 2, which is actually 1. Now AF is equal to 2. Now GF, how do I find this? We can just basically use the law of cosines. The square root of 1 square plus 2 square. I'm actually plus because minus 2ab cosine theta, but the cosine of GAF is actually negative. And GAF, the angle of GAF is actually 120 degrees. So it's basically plus 2 times 1 times 1 half. No, 2 times 1 times 2. So times cosine of theta. Well, what is the value of the cosine? The cosine is actually just equal to 1 half. So this one just simply gives us square root of 5 plus 2, which is square root of 7. Now we know that one side is square root of 7 and all 4 sides have the same length. So basically the perimeter is just 4 times square root of 7, which is simply 4 root 7. And that simply just gives us an answer choice of D. Now let's go into number 11. Let f of n be the quantity of negative 1 plus I 3 over 2 to the nth power plus the quantity negative 1 minus I 3 over 2 to the nth power, where I is equal to the square root of negative 1. What is f of 2022? So now we know roots of unity for this problem, then this one can be instantly killed. So for this problem, all I want to do is we can know that negative 1 plus I 3 over 2 to the n is actually one of the solutions to this equation. Well, x squared plus x plus 1. Well, in fact, these are actually just 2 solutions. The 2 solutions to this equation. So now this one's actually on the unit circle are just 120 degrees and 240 degrees. And by Euler's formula, then this one is actually just can be written as e to the 2 pi I over 3 to the n plus e to the 4 pi I over 3 to the n. Well, n is actually equal to 222. So this just gives us e to 2 pi I over 3 times 2022 plus e to the 4 pi I over 3 times 222. Now what is this value? This value is just essentially going to be e to the 647 times Now both of these are actually even. And we know that if e to the 2 pi I to the k, which k is actually an integer, then this is actually equal to 1. So from here we just know that both of these are just 1 plus 1 is equal to 2. Well, and by the way, to find a proof of the Euler's formula that e to the ix is equal to cosine of x plus I sine of x, just visit one of my earlier videos which I describes the Taylor series. Now let's go into number 12. Kayla rolls 4 fair 6-sided die. What is the probability that at least one of the numbers Kayla rolls is greater than 4 and at least 2 of the numbers she rolls are greater than 2? Okay. So she rolls dice, just regular dice 4 times, and what's the probability that at least one of the roll is greater than 4? And at least one of 2 numbers she rolls are greater than 2. Well, this one This one actually, if we just do casework, then actually it won't be that bad. So first, what is the probability that at least one of the numbers Kayla rolls is greater than 4? Well, basically we can just choose any number that is greater than 4, and no, what's the probability that none of the numbers Kayla rolls is greater than 4? This one is just simply 2/3 to the 4th, 16/81. Now, what about the probability that less than 2 of the numbers she rolls are greater than 2? Well, if less than the 2 of the numbers she rolls are greater than 2, then this basically just means that she either has one number that's greater than 2 or no numbers that's greater than 2. So the case there's only one number greater than 2, then we actually have 4 places, so we just have 4 choose 1. Well, 4 choose 1 place for the number to be greater than 2, and 3, 4, 5, 6, so it's gonna be 4/6. Now multiplied by the rest of them, it's just gonna be either 1 or 0. So 1/3 to the 3 power. Now what if there's no number greater than 2, then there's just plus 1/3 to the 4th. Okay, so we evaluate this number out, then this is 4/81 plus 1/81, which is 5/81. Well, this one's plus 16/81. This gives us actually 21/81. However, we have to notice the thing is that these two actually just overcounted each other, right? Because if we only have one row is greater than 4, then this actually overlaps with the case that there's exactly one number that is overlap with this case. There's exactly one number that is greater than 4. So we actually have to subtract this from the case that there's no number greater than 4. Well, there's one number greater than 4, so we'll actually have 16/81 plus 5/81 minus 1/3 to the 4th. Well, what is this one? Well, this one's basically the probability that there's actually there's exactly one number that is greater than 4, which just simply gives us 20/81. Well, keep in mind that this probably is actually the probability that this entire thing, that this statement that we want would not occur. So therefore, we want to subtract it from 1 by complementary counting, which gives us 61/81. Our answer choice D. Now let's go on to the next problem. Number 13. Number 13 says, the diagram below shows a rectangle with sides 4 and 8 and square with sides 5. 3 vertices of the square lies on 3 different sides of the rectangle as shown. What is the area of the region inside both a square and a rectangle? Now, because this is square, then we know that all 4 sides are 5. Now, well, this part is a 4 because it's just a rectangle. Now, what is this sinus? This sinus is just 3, right? Because we can see that this rectangle is a 3, 4, 5. So now we just do some angle tracing right here. So because this is a right angle, then we call this to be alpha. Then simply this angle is 90 minus alpha. Well, because it's rectangle, so this is also right angle. So therefore, this angle is alpha. Now we can see that something funny or just something important, and just that this right triangle is actually similar to this right triangle. Now analogously, we can see that it's also similar to this right triangle. Now we can just do some length tracing. So if, well, this part is actually 4, so this basically means that this part is actually 3. Well, because this entire length is equal to 4, so this means that this part is actually 1. Now, if this part is 1, then this part is actually 3/4. Now, okay, we want to find what? We want to find simply this shaded region right here. So we just say that this is actually equal to the area of the rectangle subtract by the area of the 3 separate small triangles. Now, what is actually the big area, which is just 7 times 4 is equal to 28. Now we just try to compute this area. Well, this area is just 6. This area is also 6. And this area is simply 3/8. Okay. So we just simply have 28 minus 6 times 2 minus 3/8, which is just 15 5/8. And this just gives us answer choice D. Now let's proceed to the next one. The graph of y is equal to x squared plus 2x minus 15 intersects the x-axis at points A and C. Proceeding to problem 14. Problem 14 states that the graph of y is equal to x squared plus 2x minus 15 intersects the x-axis at point A, C, and the y-axis at point B. What is the value of tangent of angle ABC? So now let's just draw the diagram, and by factoring we will get that the parabola looks something like this, and this point would actually be 3, 0, and this point would actually be -5, 0, and they are A and B respectively. So what is this point? Well, simply this point would just plug in 0 to x squared plus 2x minus 15, which this one would just simply gives us 0, -15. Now we can just draw a triangle. So you might just consider doing law of cosines, but I'll say a faster way would just be setting this angle to alpha and this angle to beta. Now consider the angle addition formula, because we know that tangent of alpha plus beta, because angle ABC is just equal to angle alpha plus angle beta. That is actually equal to what? It's equal to tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Now, this one, we can just separately find tangent alpha and tangent beta, and we're basically done. So what is value of tangent alpha? For tangent alpha, we're just going to look at this right triangle here. So this right triangle, what is this value? Well, this value is simply just 15. And this value is simply -5. Well, because of my terrible drawing, you can see that 5 is actually longer than 15, which is actually pretty humorous. And this length is actually 3. So basically, tangent alpha is actually equal to 1/3, and tangent beta is equal to 1/5. Now you can just plug into this equation. You're going to get that it's just equal to 1/3 plus 1/5 over 1 minus 1/3 times 1/5, which gives us 8 over 15 over 1 minus 1 over 15, which is equal to 8 over 14. Well, keep in mind that because both are even, you can simplify this. This one just equal to 4 over 7, which appears in our answer choice as E. Okay, now let's proceed to number 15. One of the following numbers is not divisible by any prime number less than 10, which isn't. So this one, you can see that these are all a power of 2 minus 1 or plus 1. Okay. So, this seems to be a bit interesting. So, first let's look at this number. 2 to the 602 minus 1. Well, 2 to the 606 minus 1 can actually be divisible by 2 squared minus 1. Well, you can just by taking mod 3. So we just take mod 3. This one is just equal to negative 1 to the 606 power minus 1, which is equal to 1 minus 1, which is equal to 0. So we know that right away that this choice cannot work. Now let's go on to B. 2 to the 606 plus 1. What can 2 to the 606 plus 1 be divisible by? Well, 2 to the 606 can be written as 4 to the 303 plus 1. And what is this value? Well, 4 to the 303, we can just take mod 5 to find a contradiction. So 4 is actually negative 1 mod 5. So negative 1 to the 303 plus 1. But this one is still negative 1 because 303 is odd. So therefore, this one is just equal to 0 mod 5. Which basically tells us that B is not possible because 5 is actually between 0 and 10. Now let's go on to number 3. Number 3, which is C. So 2 to the 607 minus 1. Now we check mod 3. Now we check mod 3, then this basically is negative 1 to the 607 minus 1, which is negative 2 mod 3. So we know that it's not divisible by mod 3. By 3. Now we take mod 5. Negative 2. Well, this one is not even like divisible by 4. Well, it's divisible by 4, but it's not an exponent of 4, so therefore it's not possible. Well, no, this one is not possible to be divisible by 5, so this one might be a choice, but we don't know yet. Let's go on to D. 2 to the 607 plus 1. Okay. Well, this one, same thing, mod 3. Mod 3, then this one just gives negative 1 to the 607 plus 1, which is equal to 0 mod 3. Well, yeah, so this is still not possible because this one is divisible by 3, clearly. Now let's go on to E. 2 to the 607 plus 3 to the 607. Okay. Now, this looks a bit suspicious. 2 and 3, this adds to 5, and would that actually have a connection? Well, yep. So 607 is an odd number, so we can just take mod 5 for this number. Mod 5 gives us 2 to the 607 plus, well, because 3 is congruent to negative 2 mod 5, then therefore this one's negative 2 to the 607. Now, negative 2 to the 607 can just be written as negative 1 to the 607 times 2 to the 607, which this one's negative 1. So basically this tells us that this one is just 2 to the 607 minus 2 to the 607, which is 0 mod 5. So this tells us that this one is divisible by 5. So E cannot be our answer. Now, seems like we already excluded A, B, D, and E, so therefore our answer must be C, 2 to the 607 minus 1. Okay, now let's go on to number 16. Suppose x and y are positive real numbers such that x to the y is equal to 2 to the 64th power, and log base 2x to the log base 2y is equal to 2 to the 7. What is the greatest positive value of log base 2y? Now, a pretty intuitive way to think about this is possibly just let x be equal to 2 to the m, y is equal to 2 to the n. Then we have 2 to the m times 2 to the n is actually equal to 2 to the 64. And we also have log base 2x, which is equal to m, log base 2y, which is equal to n. That is equal to 2 to the 7. Okay. Then we see that because m to the n is equal to 2 to the 7, and m times 2 to the n is equal to 64, so m must be power of 2. So m is a power of 2. So let's say that m is equal to 2 to the alpha's power. Then we actually have 2 to the alpha times 2 to the n. Have the system, which is 2 to the alpha times 2 to the n is equal to 64. And 2 to the alpha times its power is equal to 2 to the 7. So basically this transforms to alpha plus n is equal to 6 alpha times n is equal to 7. Now, this one can be just transformed into a quadratic, which has a solution of simply x squared minus 6x plus 7. Well, if you don't believe this, you can just try to use Vieta's formula, or you just separate alpha in terms of n or n in terms of alpha. You're going to get the same result. So now, from here, this one's equal to 0. Okay. Now let's just check the discriminant to make sure that we actually are on the right track. This one is 6 squared minus 4 times 7 is equal to 8, so it's positive. Now let's just solve it. So this one is just 6 squared. So 6 plus or minus square root of 6 squared minus, well, we already know that's square root of 8 over 2, which is equal to 3 plus or minus square root of 8, square root of 2. Now let's see what problem we want to find. We want to find the greatest possible value of log x y. So therefore the answer would just be 3 plus square root of 2, which gives us an answer choice C. Thank you for watching for this episode, and in the next episode we're going to start doing the late half of this test, which starting from 17 to final 5 and eventually to number 25. Stay tuned, and I'll catch you in the next video.